Welcome to this session on Gen 7 Fiber Channel and the autonomous SAN. My name is Marcus Thordal. I'm a Principal Solutions Architect in the Brocade Storage Networking Division in Broadcom. And I'm here today together with AJ Casamento, also Principal Solutions Architect at Broadcom. And we get a lot of questions from customers, why Gen 7? So AJ, let's talk a little bit about the need for Gen 7 Fiber Channel.
Yeah, I think that most of the customers are going to be pretty well aware of the shift that's been going on in the technology. So, with better than 70% of the enterprise arrays that are hitting the floor being all flash, the performance strains on the existing infrastructure has been pushing higher and higher. And we've actually seen a lot of customers move to Fiber Channel explicitly in order to be able to take advantage of the flash platforms. And now the analysts, Marcus, are telling us that in 2021, maybe 50% of the enterprise arrays that hit the floor are going to include non-volatile memory express technology, right? At that point, the latencies drop again, the performance goes up again. We've got big drivers in terms of artificial intelligence and machine learning going on in the market, and I think you would agree that there's pretty much no part of our world that's not going to get touched by AI at some stage. Most of our customers in the infrastructure teams, anyway, are being pushed as a comparison to cloud. You get the application guy who says, hey, if this was Amazon Web Services, 10 minutes with my credit card and I don't have to talk to any of you people. And so the agility piece that needs to be there in terms of rapid deployment, and then as well, they're not getting additional headcount, so they need the ability to have a simpler level of management, right? And all that's going to continue to be driven in the impact of the platforms that are being connected. So if we look at the servers and so on, the next gen platforms, more CPU, more cores in the CPU, moving from Gen 3 PCIe to Gen 4 PCIe, going from 32 gig per device connectivity to 64 gig per device connectivity, and so on. As you're well aware, the advent of not only NVMe, but discussions around storage class memories in the storage environments, right? Where does the stress level stop, Marcus?
What I'm often telling customers when they today look at their SAN infrastructure is that they shouldn't plan for today only and what's available today. They all know that when they put in a new SAN, it's going to last maybe 5 years or even a little bit longer than that. And throughout that lifetime, they have to be able to support multiple generations of servers, storage, and as you just mentioned, the application architecture is going to change to take advantage of NVMe as well within the next 5 years. I'm sure we're going to start seeing that.
You really want to do exactly what you just said, and architect for multiple generations. And again, nobody's suggesting to the customer that they're gonna wipe out everything they have every 2 years and put in brand new. But what if on your next refresh cycle, what if the next array that you need to buy because you need more storage capacity, right? Or the next servers you want to buy are the next iteration of that platform, right? So with lower latency and more capacity behind it, because we're already looking at, as you know very well, Marcus, storage arrays that provide multiple petabytes of high speed, highly performant, very low latency, lossless deterministic storage delivery, right? Non-volatile memory express or NAND, right? That sits in a 2U rack, right? Things that used to take up 3 full racks of space on the floor are now tiny by comparison, right? That scale is going to continue to go, and it's going to go at 18 to 24 month cycles in the silicon. And so the fabric needs to be able to cope with at least a couple of generations of that, right? And then be able to take new adaptations as well.
Can you tell me a little bit more, what is really the concept of an autonomous SAN that we're bringing with the Gen 7 Fiber Channel?
With every step in the storage technologies, the latencies come down, the number of IOPS go up, and then as we double the rate on the SAN itself, as we go from Gen 6 at 32 gig to Gen 7 at 64 gig, right? And we double the data rate on the cable again. You start thinking about that, and then you have to ask yourself, okay, at what point are humans going to be fast enough? And really, Marcus, I don't think they can be anymore, right? The concept of, wait until something breaks and you pop a light someplace in somebody's view, and then the human goes to begin analysis, right? That's not going to work. That's not going to be supportable. Your mean time to repair isn't going to be fast enough, right? And so from the autonomous SAN side from our technology, what we look at is we need the environment to be self-learning, right? Because you need a baseline. You need to know what normal looks like. If you don't know what normal looks like, how do you know when you've got a problem? And at the same time, we want it to optimize. So if at all possible, we'd like to clear the weeds, right? Get rid of a lot of the nagging ankle biter kinds of problems that people run into. And in particular, one of those is the mix of generational technologies on the floor, because customers don't get to just throw everything away every 2 years and bring in brand new. And then as well, self-healing, Marcus, right? Because at some stage, if we can mitigate the problem automatically, we're the fabric, right? We see all the connectivity, we see all the devices, we know when things are going on. And if we can help to mitigate that until the human can get to it, till the admin can get to it, so the self-learning, self-optimizing, self-healing, that's the autonomous SAN. And it's that level of technology, I think, that you're going to see a pervasive need for in data centers. I don't know how else people will keep up. I really don't.
So AJ, let's talk a little bit more about what really enables that. What is the instrumentation that enables self-learning, self-healing, but also the data foundation to make those decisions? Can you tell us a little bit about what's really the foundation and how is it all enabled?
The Condor 5 ASIC, which is the core backbone of the autonomous SAN, has a huge amount of telemetry built into it. And there's reasons why we do that, Marcus. Inspection always carries an overhead. That's true no matter what you do. If you're going to look at something in detail, particularly in a very granular detail, then there's an overhead assigned to that. There's a cost in doing that. We actually build the telemetry into the ASIC so that you don't have to pay that penalty, for the inspection, right? And that ability to measure, as an example, when you turn on fabric performance impact monitoring in our SANs, we're actually looking at the latency of the buffer credit returns millions of times a second on every port in the SAN. Now, no customer is going to want to see those measurements, Marcus, right? In that kind of granular detail. But that baseline is what allows us to know when there's a problem, when there's a slow drain performer, and mitigate that problem, rapidly, right? That matters to people. Maybe not, maybe they don't want to know the gruesome detail of how the measurement's actually done, but they want that result. They need it, actually.
Yeah, you bring up a very good point. I sat down with a customer last week and we were doing a hands-on tutorial on SANNav with FOSS9, and I showed him how basically the fabric now automatically self-learns all the flows and then illustrates them in SANNav. And not only that, as you mentioned before, you obviously don't want to look at every data point multiple times every second, but rather the up-leveling of those data points when some kind of anomaly or recognizable problem was detected, and then with some guidance on what to do. And so in the respect to SANNav here, it basically said, there's congestion happening here, and this is the root cause for the congestion, and then you could drill in and get more information about exactly why it happened. And so I think a very good example of this self-learning capability, and then at the same time delivering it back to the end user in a consumable format so they can do something actionable with that information.
I think one of the key things you just mentioned there is the self-learning piece of that, because if the admin has to go in and set up all the measurements manually, there's no way they won't make use of that, because they just don't have the time in their day. And so the concept that we're going to auto learn, tens of thousands of flows per switch for them to build that baseline and populate the data into SANNav the way you're describing, that gives you that baseline, that gives you the ability to see what's actually going on.
Yeah, and once you have that self-learning capability, then you open up for new capabilities in the autonomous SAN. And you mentioned the self-optimization. Can you tell us a little bit more about what is self-optimization, or what is the first step in that direction?
Yeah, so I mentioned before that one of the challenges that a lot of our customers have, and I mean you see this all the time. We talk to a lot of the same customers. They've got multiple generations of technology on the floor. I mean, we've got some customers that are running gear, that they've had for years, and not necessarily because it's their favorite pet and they can't bear to part with it, but because it's a mission critical application that runs in that particular platform, and they don't have an alternative for it at the moment, right? So what do you do about that? Because that then drops into one of my favorite analogies of, me being the grandfather in the family car out on the highway, right? And somebody like yourself who's a more performant driver, shall we say, being behind me, and I'm not breaking any laws, but you've got places to be, and you don't want to be stuck in that position. And so what we're doing, based on a very simple definition that we have for congestion, which is frames are entering the fabric faster than they're leaving the fabric. The self-optimizing piece of this is that we will look at where the traffic's going to. We look at the destination. How fast can the destination accept the data, right? And then we will pre-sort the flows going to that destination into a performance group that matches that speed. So if it's a 32 gig array port, we'll send traffic to it that'll drop into a 32 gig performance group. If the return traffic is coming back to a 16 gig server, you don't want to try and feed that at 32 gig. You're just going to create back pressure in the environment, and so we'll drop that flow back from the 32 gig array to the 16 gig server into a 16 gig performance group, right? So that you're not mixing those traffic patterns, and Grandpa isn't keeping you from getting where you need to be on time. The fact that that's done automatically, that's something, Marcus, that I think customers are going to really, really love, because you don't, just like with the auto learning of flows, you don't have to set it up. You don't have to spend hours initially creating the environments you want to look at, right? All of this is going to happen in an automated fashion. And what it's going to do is it's going to get rid of a lot of the weeds. It's going to get rid of a lot of the base level interactions, right, for you, and it does it automatically. So that's comfort food. The way I describe that these days is, that's like your mom, making you toasted cheese sandwiches and tomato soup on a cold day, right? Those are the things that are going to make the operational day better for the sysadmin, and that matters to people.
Over the years, we've had a lot of customers who've had exactly that problem you talked about with, slower moving traffic that still needs to go somewhere as well, just not as fast. And so we were able to reactively handle that and mitigate the impact of it. I think with the traffic optimization, it's really a matter of doing that completely proactively. And so again, removing the need to constantly go in and nurse and understand what's going on in the fabric, but really let the fabric, who has all the information to make the right decisions, take care of this completely proactively.
And you make an excellent point there, Marcus, because one of the things that's very different about Fibre Channel than other technologies is the way Fibre Channel configures. And so it's an automated environment. As you connect devices into a Fibre Channel SAM, first we configure the fabric. We know where all the connectivity is. And then as the devices get connected, they log in and get registered into the name service. We know the devices. We know what they are. We know what their speeds are. We know how their speed match, right? All that happens automatically. It's from that database that we can pull the data that allows us to do the traffic optimization in an automated fashion, right? And so that's something that's extremely difficult for anybody else to do and would have to be done manually. We do that in an automated fashion, and people don't even have to think about it.
Yeah, and I think let's talk a little bit about the third pillar as well, the self-healing, which is completely new and I think in many ways groundbreaking when we look at just networking technologies in general, but also from a SAN perspective with the self-healing capabilities. Can you tell us a little bit about that?
Yeah, so there's a new technology that's introduced here called Fabric Performance Impact Notification. So that sounds a little complex, but the reality of the situation is, as I mentioned, as the fabric, Marcus, we have the ability to know when things are happening. We know when a server, for example, stops responding to us. We know when somebody's oversubscribed. We can see this. We can see when there's a link integrity issue, right? But we're the connectivity piece. Wouldn't it be really, really cool if we could signal to the devices attached what's going on so they can help with the mitigation of the problem, so they can know how to respond to that? And that's what's going on here. And again, this is something that's not readily manageable in other technologies unless you're willing to make some alert that pops some upper level stack that drops off to another application and eventually comes back. But we're talking at a wire level, being able to signal at a very low latency. And so it's a new management service, yes, but it's a new signaling level in band that lets us respond very, very quickly, Marcus. So we'll see, if there's congestion on the link, if there's a link integrity issue, and be able to talk to the server that's attached to get help in mitigating that problem. Yes, we can still do the things that we do in the fabric, no question, right? But if we can identify to the array, for example, that the device it's talking to is oversubscribed and have the array have the opportunity to throttle back, as an example, right? Those kinds of things can be a significant help to mitigating the problem immediately. The system administrator, the SAN administrator, is still going to get told about it, Marcus. We're not suggesting that that they won't be, but then they can come in and they can review what was done. They can review how we mitigated it, right? And decide, is that a permanent fix or a good enough fix, or do I need to maybe I need to load balance that array port better, right? I need to move some servers to something else, or some workloads to something else. And so, that piece of it, right? So the low-level signaling for congestion notification, as well as one of your particular favorites, Marcus, the sick but not dead link. You want to maybe provide some color around the MPIO piece for that.
It's important to mention that everything we talked about here is already available, right? It's GA. There is already, self-learning of flows. There's already self-optimization. But even the part with the self-healing, where the devices have to actively take part to make this happen, it's already available as well, both from a congestion mitigation capability, but also with the link integrity issue that you mentioned here with the sick but not dead. Again, it's a problem we've seen in customer environments the last many years, where you have a link integrity issue on a redundant path, but the multipath driver or software still puts traffic on that path, and sometimes it fails because you have an intermittent error on that path. And when that happens, the upper layer protocol, SCSI, would have to do a recovery, and now the application is waiting for a timeout to pass through or exceed, and then finally it can transmit traffic again. And that obviously creates a application performance issue, and being able to mitigate that completely automatically is something that's already available with some multipath drivers, depending on operating system. And again, here, it speaks back to the support and the ecosystem commitment to make Fibre Channel really the best network for storage traffic.
And I think that's a critical point that you bring up there, Marcus, because there is a huge amount of commitment in the Fibre Channel industry to making all of this work together, right? So with the host bus adapters and with the array controllers, and the level of testing that goes on here is so much different than it is in any other connectivity. And so we know what the devices are. We qualify against all the devices that are being attached, and that gives us a significant advantage there as well. We can already begin to understand what the behavior patterns are of the technologies that are being attached to the environment. But the base level is that these are things that we're doing, that we're stepping ahead and providing a self-healing function in these environments as well. It's going to be something that people are going to need. Back to my previous comment or question, Marcus, how are humans going to be fast enough? And if humans can't be fast enough, then we have to be the first step. We have to do the mitigation up front, right? And I think you would agree with that.
Yeah, and I think another point is, very often it's the same pattern we see again and again that is basically leading to the same result or based on the same root cause, and being able to identify that as fast as possible. There's no better place than the SAN itself. So AJ, how does the autonomous SAN really work?
Well, so we talked about the concept of the self-learning for flows. What's actually going to happen in Gen 7 is that for every switch or director, we're going to automatically learn 20,000 flows. That's initiator to target, or think about it as server, application on the server talking to the data in the storage, right? We're going to learn 20,000 of those flows. And because of the volume of that data and the volume of the measurements that we're doing, Marcus, we're going to stream that data off the switches using Kafka into SANNav as our collector. And then within SANNav, we get the visualization, right? And so that's one of the critical things, I think, for us to make sure customers have a comfort level with is, we're not going to drown you in metadata about your data. That would be foolish. We're going to be able to show you, because we know what the baselines are, where your problem spots are, right? As you're always talking, Marcus, about where the top congested ports are and so on.
So you're basically saying by going into SANNav, I can see all these flows. I can pick one at a time, or maybe even multiple, and then look at different metrics across those flows, as well as SANNav will give me some understanding of how these relate to an event or something of interest.
Yeah, exactly. Because when the alert comes, right, or when we see an issue, or as we start to learn about an issue, what's the scope of that issue? Is it something that affects just a single flow on a single server? Is it something that's storage port related, where there might be 10 or 15 or 20 or more servers talking to the same storage port? So knowing what you want to look at, what read rates, transmit rates, latencies for the exchange completion times, pending IO on the port. Those are all characteristics that you may want to look at, but you don't necessarily want to be inundated with all that until you have a first glance to see, okay, here's my problem spot. Here's what the health status is telling me, and I drill down in, and okay, now I want to look at these elements of these flows or these multiples of flows. Yeah, exactly.
Okay, great. So I can see everything that the SAN basically learned about the flows. We also talked about that the SAN is able to optimize based on what it knows about the flows. How does that really work?
Well, as I mentioned before, one of the things that's interesting about Fibre Channel is this concept of this auto configuration. In point of fact, that's one of the things that some of the alternative technologies in the Ethernet space and so on for NVMe are beginning 3-year, 4-year development programs to try and create some of this software, because we automatically register devices. We see what comes in. We know what the devices are. And so by that same data, we know what the device is capable of. It's negotiated a speed to us. We know what it is. We know what it can handle. And so because of our definition of congestion being frames entering the fabric faster than they're leaving the fabric, what we want to do is speed match. And we speed match into performance groups. And so on the interswitch links between our switches, and that's sort of what you're seeing in the diagram, that single interswitch link has multiple virtual channels. So think about it, Marcus, a little like multiple lanes across a bridge on the river, right? And what if instead of having, Marcus stuck behind AJ as AJ's driving to go see the grandkids, you've got a scenario where, there's a lane for grandparents, and then there's a lane for, for parents that are trying to make it to the soccer match, or, whatever it is, and so on, right? If we can sort the traffic based on the performance of the devices that they're talking to, we avoid a lot of the interaction problems that happen when you have multiple generations of technology in play on the floor. And you made a point before, Marcus, about the application is still critical, right? It could be an order entry system. It could be a payment card information system. It could be medical records, right? It's not like you should be allowed to just drop the data. So by being able to sort this up front, the hope is, and the intent is, that we're going to dampen down a lot of the interaction problems that we see between multiple generations of devices in the same SAN fabric, and that's going to be a significant win for us, because it means that the number of incidents where things actually do happen is going to drop way down. And the cool thing is, you don't have to think about it. So when you have this running in Gen 7, and it's a default environment, we're going to automatically sort those traffics into groups based on the capability of the device that's receiving them to take that data in, and thereby avoid the congestion in the fabric to begin with. Because the best traffic management is not to have traffic congestion to begin with.
Very good point. And we also talked about earlier that in next generations, we're even going to do this separation of traffic based on protocol as well, right? Because there will be different performance groups associated with different protocols. Obviously, what I'm thinking about here is NVMe coming into the SAN and running in parallel or together with SCSI on the same physical infrastructure.
Yeah, and that's an excellent point, Marcus, because people lose track. They get wrapped up in the idea of NVMe as hardware. And yes, there are NVMe capable devices or devices which talk NVMe into the system. But as you know from your conversations with customers, one of the big surprises to many of them is that it's a new language for talking to memory, and which is what the storage devices are these days, whether we're NAND or NVMe or storage class memory, they're memory devices. And so the benefit on the server stack is huge, and the reduction in overhead on the server stack is huge. And so at some point, the thought is, if we can also pre-sort based on protocol, right, then you don't have NVMe traffic, which can cut through on a short path, if you will, stuck behind the SCSI traffic, which is going to be taking the long road.
So I want to touch a little bit more on congestion, since congestion is obviously something that is very common in customer environments today. And we already mentioned, how with Traffic Optimizer, the idea here really is to proactively avoid congestion from happening. But there are some congestion cases that cannot be handled by Traffic Optimizer. And so before we go into how we're going to handle those and the enhancements there, let's just clarify again, what are the different kinds of congestion that can happen? As AJ mentioned, when congestion happens, it's really because frames cannot be taken off the fabric in a timely fashion. This happens because of lost credits, or because a device is doing a credit stall, or finally oversubscription, where the oversubscription case can in most cases be handled proactively with Traffic Optimizer. But for the other two, well, actually for all three, there are enhancements available today. And AJ, let's talk a little bit more about what those enhancements are and how they actually work.
Yeah, so fair enough, Marcus, right? There's, one always tries to architect so that there are never any problems, but you have to have mechanisms in place that can handle the problems when they do occur, right? It would be foolish not to. And I think one of the real benefits that we get out of the new Fabric Performance Impact Notification, or FPIN, piece of the Fiber Channel standard is this ability that doesn't exist in other technologies today to have a low-level, hardware-level signaling effort. So the ELS piece that we can do on the link to push a status to the edge device, right? Because they're part of the ecosystem with us. And the switch is part of the ecosystem. The host bus adapter and the server itself is part of the ecosystem. The host bus adapter and the storage array itself is part of the ecosystem. And so by being able to signal to the other devices in the ecosystem what's going on and what the trouble is, we get a better opportunity to mitigate. And so there's the service level, the software service level piece of this, right, where we can handle the messaging, right? And then there's the low level link messaging, which has a very low latency in Gen 7, to be able to identify to, say, the server platform that we've got lost credit on the link, right? And so then handle the recovery mechanism for that, or that it's a credit stall. The server is stuck and not responding with an R ready, right? And we can handle that as well, right? Pop the server and say, hey, we've got to correct this, right? Or to your point, the oversubscription, right? Does the server realize that it's actually creating the back pressure into the network that's causing the bad response time for neighbors, right? Because there's that situation, right? Of having we sometimes refer to as bully flows and victim flows, right? Where one of the applications is stepping on another application and causing a bad response time.
Yeah, and I think the most important part is that the root cause of the problem doesn't really know that it's creating a problem. And what we can do with the Fabric is we can see end to end that one device is causing the problem because it's oversubscribed, for example, and then we can notify the devices that are talking to each other, the one that's creating the oversubscription and the device it's talking to, and we can have them mitigated on their own, things that we really couldn't handle necessarily in the Fabric itself. So if we look at Gen 7 from an overall perspective, AJ, what's really included in Gen 7? There's obviously some hardware and a lot of capabilities that we already talked about. Can we touch a little bit on what's really included in Gen 7 today?
Yeah, so I think there's this mix of in the hardware platforms themselves. We absolutely have performance. We've doubled the throughput at a link speed. We've cut the latency in half, Marcus. So at an ASIC level, we're sub half a microsecond now in the ASIC, any inbound port to any outbound port. We've built in the telemetry into the environment to be able to handle a wide range of analytics that are going to happen automatically. And then as well, the ability to cope with the non-volatile memory express environment. And so when I say cope, with non-disruptively cope, right? The ability to take this new technology in, to take in a new language that we're going to talk across the same infrastructure markets, across the same HBAs, across the same switches to the same storage, right? And potentially the ability to run those concurrently in the environment, right? And that's I think pretty critical, because as I said before, people don't get to just sweep the floor of everything and start new every 2 years. It doesn't work that way for most customers.
Yeah, and that I'm very excited about NVMe. One of my taglines is, this is truly just the beginning, AJ. What we're seeing right now is we're just on the early shores of adopting NVMe, and we can see great performance improvements by doing so, reducing CPU usage, etc. But really, if we look at what's coming over the next few years, what we can already predict is obviously higher performing servers, higher PCIe capabilities, and then there's the whole parallelism capability with multiple IO queues. So let's talk a little bit about these Gen 7 platforms. There's obviously a director product and a switch product. Can you take us through the details on that?
We introduced 2 directors and 1 fixed port switch. We introduced the X7 directors, both the 8-slot and the 4-slot directors. With the 8-slot director, you've got the ability to go up to 384 ports at line rate 64 gig. That's non-blocking, not oversubscribed. And that's the platform that people really should be thinking about. So when you think about investment protection, and you think about all the conversations we were just having about, what people are going to be facing in terms of Moore's law applying to all the devices that are attaching in the SAN now, because both the storage and the servers now are going to be living with Moore's law, then that's the platform that's going to get you the longevity, Marcus. That's the platform that's going to allow you to continue to connect devices as these new families come in. Right. And yes, I understand that people think, well, I don't really need 64 gig today, but keep in mind, it's the other feature sets you really want to make sure are in play. It's the traffic optimizer. It's the auto learning of 20,000 flows per platform. It's the ability to have the fabric performance impact notification, the congestion notification pieces in play there. All of those things, along with the longevity of being able to see this SAN fabric in place through the depreciation schedule of the platform for all the devices and all the technologies that are going to be coming in. And then as well in the X7-4 director, which is 4 slots, very similar to the same version in the X6 director chassis, and can go to 192 ports at 64 gig with the same blades, or up to 256 ports of 32 gig with the X6 32 gig blade for that environment. So same blades can be matched between them, and you've got your X7 directors with much higher performance and much better longevity. The G720 is the new platform that we just introduced for the fixed port switches. So this is really interesting, because it's a 1U switch that goes from 24 ports as a starting point up to 56 ports in this 1U at 64 gig line rate, non-blocking, not oversubscribed. And one of the really cool things about how this got done is that in this generation of the switch, all of the optional licenses are included in this switch, right? So you don't have to worry about, oh, did I remember to get this license, or did I remember to get that license, or if I'm adding these 8 ports to one or more of the devices on these 8 ports need one of these extra special licenses, what am I going to do about that? No, all the optional licenses are included. And then one of the really cool things, I think, that has had multiple customers virtually standing up and cheering at their desks is that in FOSS9 on these platforms, the Web Tools element, which is the element manager for looking at a single device, a single switch in the environment, is now Java free. There's no more Java runtime engines, and customers get pretty enthusiastic about that. And the user interface is brand new as well, and looks very much like the SANNav user interface. So I think that's a really nice package for our first switch delivery in this environment.
So this was the overview of Gen 7 and the autonomous SAN. Thank you for watching. AJ, Any additional comments that you want everybody to keep in mind?
I think the thing that I really want customers to walk away from this with is that while the hardware platform and the base environment is going to be the thing that gets them through into the next generations of technologies, it's the autonomous SAN piece of this that's really going to be the benefit to them in the short term. You know, the concept, Marcus, that the platform gives us or enables self-learning, self-optimizing, and self-healing, right, is something that is going to be very unique to these environments and extremely good for any administrator who's trying to make their operational day better.